Hi, scholars, and welcome to Module 4, Lesson 5. Let's go ahead and begin with our objective. Repeat after me. Today I'll be able to explore benchmark angles using a protractor. Now, a protractor is a tool that we use to help measure angles and measurement. And we understand you don't have one at home, but that's okay. Today in Zearn, you're going to have the opportunity to understand what a protractor is, to see what it looks like, and to use a digital one. But we do want to create something at home for you to be able to work with today. So I'd like to invite you to follow along with me as I create my own protractor using two different color sheets of paper. So grab any two colored papers that you might have at home. And once you have those, go ahead and continue this video. Pause now if you need to go get those. All right, so using these two pieces of paper, I want you to line them up front to back. Mine are black and white, but they can be any colors, anything that you have at home. Grab your scissors from the pencil pouch in your binder, and together let's cut out a circle the best that we can using these two sheets of paper. Now, it's not going to be perfect, but it will give us an idea. Now, I've got my two circles lined up. Now, coming and finding in that center point, I want you to cut a radius into the center of your circle. And now I can see that I've cut a line here through the middle, and it looks almost like a Mr. Pac-Man a little bit if you were to move it. Taking this, I want you to slide one paper past the other through the slit. And this is how we are going to be able to look at some measurement angles today to better understand how a protractor helps us find angle measurement. For example, I can turn it slightly and I have a little acute angle here. I can turn it at a 90-degree angle. We've made a right angle. Great. If I add another right angle, I now have a straight line or 180 degrees. If I turn for my third right angle, 3/4 of the circle, I can add 180 degrees plus 90 degrees to get this angle. Or I could do a full turn and get my whole 360, which is my two lines put together. As you notice, 180 plus 180 makes 360. So now we've created our own visual protractor tools that we can use throughout these lessons. So go ahead and hold on to these. And today we actually have a learning lab. So we're going to work together with our protractors, and I'm going to guide you. And we're going to work through using this tool together to find these benchmark angles.
Make a quarter turn.
All right, scholars. So using our protractors, we're going to make a quarter turn. A quarter is 1/4. Please say the fraction, 1/4. Go ahead and take your protractors and let's make 1/4 of a turn, or as you might have recognized, a 90-degree angle. So I'm going to go ahead and grab this tool here and I'm going to turn it to 1/4, or that 90-degree angle. Great job.
What angle does a quarter turn make?
Great. Some of you might have realized that you see a 90-degree angle here. If you have your straight edge from the first lesson, then you can line that up and see that, yes, you do indeed have a 90-degree angle or right angle. So let's go ahead and record that learning in our notes today, where you have your objective written. Go ahead and draw your circle. And if we start with our radius, the center of our circle, and we go up, then right here we have a 90-degree right angle. Excellent. All right, let's now go ahead and make another quarter turn to the left. So as we keep turning, one more fourth, or we now have 1/4 plus 1/4, which is 2/4. What do we see here? Let's make this turn together on Zearn. Exactly, I now see a straight line. Nice. Okay, so how far have we turned in total?
How far around the circle have you turned in total?
We turned 1/4 plus one more fourth, which is 2/4 or half. Excellent. Let's go ahead and record this. We now have our circle. We started here, we turned, and we did 1/4 of a turn, 2/4 of a turn, and we now have a straight line, which this arch is now 90 degrees plus 90 degrees, or a total of 180 degrees. Excellent. So we now have, scholars, let's write this down, a straight angle. Excellent, or 180 degrees. Let's go ahead and keep turning using these great protractor tools that we made.
Make another quarter turn so the blue ray points down.
Okay, so we turned 1/4 plus 1/4, which is 2/4. Now we're going to turn that third fourth. So we have 3/4 of a turn here. Let's also show that, scholars, with our protractor tools, where we've got 3/4 of a turn. And before we go ahead and complete that circle, let's draw what we just did. Next, we took our circle. We started at 0 degrees. We went up to 90 for 1/4 of a turn. We kept turning for 2/4, or 180 degrees. And then we continued turning until we made that third quarter turn. So we have 90 degrees plus 90 degrees plus 90 degrees. Or, here's our measurements. We can say if we have a line, our 2/4 is 180 degrees, plus our third turn of 90, how far did we turn? What is that 3/4 of a turn angle measurement? Go ahead and work on your whiteboards and solve this. Let's take a second to look at that. Let's go ahead and check it together. 0 plus 0 is 0. 8 plus 9 is, that's right, 17. And 1 plus 1 is 2. So this angle measurement here, if we put an arc there, measures 270 degrees. Great, scholars. Let's go ahead and dive back into our learning lab. So now we want to continue to make another quarter turn until we've made a full turn.
Make another quarter turn to complete a full turn.
So let's take this arrow and bring it all the way back to where we started. And scholars, in our protractors here, we've made 3/4 of a turn. Let's now make the whole 4/4 to make our complete circle.
You've made a full turn. How many 1/4 turns did it take?
Let's take a look. On our board, scholars, let's draw our full circle. It's kind of starting to look like Pokemon balls to me. As we started here with our radius, we turned once for 1/4, twice for 2/4, 3 turns for 3/4, and all the way back for 4/4. We made 4/4 of a turn, or one whole as we review our fractions. Each of these is 90-degree angles. We have 90 plus 90 to make 180, plus 90 to make 3/4, which is 270 degrees, or plus an additional 90 to make our whole turn. Now we can add up 90 4 times, or we can take a look at our straight angle and realize in one circle that we have 2 straight angles, 1 and 2. So I can add 180 plus 180 to find the measurement of the whole circle. Go ahead and on your boards or in your notes, add, and what is the measurement of an entire circle? How many degrees would that be if we made all 4 turns? Let's check that math together. 0 plus 0 is 0, 8 plus 8 is 16, and 1 plus 1 plus 1 is 3. That's correct. This is a 360-degree angle. So a circle measures 360 degrees. No matter how large or small that circle is, those measurements will remain the same. Once you have your notes, let's go ahead and dive back in. Please pause if you need to.
You've made a full turn. How many 1/4 turns did it take?
So how many turns did it take? Well, we turned 1, 2, 3, 4 times to make 4 out of the 4 turns. So 4 quarter turns. Great work.
Nice job. What if we break up a full turn into 8 equal parts instead of 4? Sophie, how would you start making 1/8 turns?
To make my first turn, I would turn a ray 1/8 of the way around the circle. Then I can keep going 1/8 at a time until I get all the way around the circle.
All right, so let's now show 1/8 of a turn. If we were to take our circles, and now we are taking our fourths, but we are almost dissecting them in half. So we're multiplying this by 2 to make eighths. I have twice as many parts, even though they are smaller. Taking my fourths and multiplying by 2 to get eighths. So let's make 1/8 of a turn. We have an acute angle here. We're also going to take our angle protractor tool and we're going to make that turn. Great job, scholars.
Is a 1/8 turn greater than, less than, or equal to a 1/4 turn?
Let's take a look at those measurements. For 1/4, I had this angle, which is twice as many parts as an eighth. So 2/8 is equivalent to 1/4. So it's asking us, is an eighth turn greater or less than? And it is less than. Great use of your fraction knowledge to help you with angle measurements.
Move the ray to complete a full turn. How many 1/8 turns does it take to make a full turn around the circle?
Well, if we're counting by eighths, how many eighths would make the whole circle? We would have to move all 8 of the circles. So let's take a look. This is 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. When the numerator and denominator are the same, we know we have one whole. Just like 4/4 equaled the whole, 8/8 would equal the whole here. So it takes 8 1/8 turns to make a full turn. How many 1/8 turn to make a full turn? What happened? Let's see. Let's try again. I think my screen's not working right now. Oh, I had to turn here. Here we go. Okay, let's try that again. Okay, we did get that correct. I'm sorry, scholars. My mouse is just being a little silly right now. Here we go.
Let's think about what we did. Lucas, how many turns does it take to get all the way around the circle?
When we make fourth turns, it takes us 4 turns to get around the circle. 1/8 turns are smaller than 1/4 turns, so it takes more 1/8 turns to get around the circle. It takes 8 1/8 turns to get all the way around.
Nice. Can you figure out how many 1/100th turns it would take to make a full turn?
Well, scholars, we know the numerator and denominator need to be the same to make the whole, so we would then say that it would be a 100 hundredths. All right, let's continue with our circle up activity. So let's take a look. How many hundredths would we need? That's right, we would need 100. Let's continue. We had 1 out of 360 degrees. Now we know 360 degrees is our full turn. So 1 degree would be a very, very acute angle out of the 360 it would take to make the full circle. So we would need all 360 to make that full circle. Great.
Nice job. When each turn is 1/360th, it takes 360 turns to make a full circle. We have a special name for 1/360th of a full turn. It's called a degree. There are 360 degrees in one full turn.
All right, so as our Zearn coach told us, there are 360 degrees in a full turn. So 1 degree is actually 1 out of 360 degrees in that full turn. Great.
Let's take a closer look at degrees. A degree is the unit that we use to measure angles. Since a full circle always has 360 degrees, we use a full circle marked with 360 degrees as a tool to measure the number of degrees in any angle. We call this tool a protractor.
Okay, so here's our protractor tool. And as I mentioned, Scholar, that 1 degree means that it's actually 1 out of 360 turns around that circle.
How many degrees are in a full circle?
So let's review. There are 360 degrees in a full circle. Great.
We can use a protractor to measure the number of degrees in any angle. Let's look at how it works. The protractor has a line from 0 to the center. This is the 0 line. It's the starting point from where we measure angles. If we line up the vertex of the angle with the center of the protractor, we can measure an angle like this. This angle is 30 degrees. This angle is 45 degrees. Now it's your turn. Try it out.
All right, scholars, now you can go ahead and finish up with your Circle Up independent activity today, or log into or open up your Learn books and practice there today, doing your best with your protractor knowledge and your protractor tools. Have a great day, Zearning scholars. Bye.